Well, here again, let's solve this parallel sailing problem. Here a ship traveled from A, which is 50 degree 25 minute north, to 048 degree 20 minute west, and reached to position B, which is 50 degree 25 minute north and 38 degree west. Find the distance covered. Well, this is also a similar question. So here what we notice here, that the latitude is same. So let me write here, latitude is same. That means vessel is doing parallel sailing. So if the vessel is doing parallel sailing, we have this parallel sailing formula, which says departure is equal to d long into cos of latitude. Now let's find what is d long. Well, this is for place A. The latitude is the longitude is 048 degree 20 minute west, and for B it is 038 degree, and I can write here 00 minute west. So from here 048 to 038. Well, the d long here from A to B is from 48 to 38. From more west you are going to go to less west, so you are in the easterly direction, and here the value will be, if we see carefully, it is 10 degree and 20 minute. If I convert 10 degree, that is 600, so plus 20, that is 620 minute east. Now coming back, let's find departure. The departure is 620 into cos of latitude, and which is 50 degree 25 minute. Now let's start with the calci. I think that will really help. Okay, so let me just start it. All right, let's punch in 620 multiplied by cos 50 degree and 25 minute, and then you put degree again, so you get this 395. 395, we can round off to 395, so let's put it here, 395, and this will be minutes and towards east. But we know it very well, since vessel is doing parallel sailing, we know it that departure is equal to distance. Hence distance will be 395 nautical mile. That is the answer. Now let's do another problem. And in this problem, a ship traveled from a position A 50, okay, let's highlight it, 56 degree 56.6 and 040 15 minute west, and started steering a course of 270 and covered a distance of 120 nautical mile. Let's find the arrival position. Say, suppose this is the position A and the vessel moves in this direction, which is 270 degree true, and the distance moved is 120 nautical mile. We need to find this arrival position. We need to find the arrival position. Well, we should know that if the course is east or west, vessel is doing parallel sailing. So here the course is 270 degree true. That means vessel is doing parallel sailing. That means vessel is doing parallel sailing. So if you are doing parallel sailing, that means the departure is equal to d long into cos of latitude. Now another aspect, in parallel sailing, departure is equal to distance. Departure is equal to distance. But we know it very well, the distance is already given, which is 100 20 nautical mile. And since the vessel is, this is 270 in the westerly direction, the departure has to be in westerly direction. This will be the departure. So if we write here 120 minute, let me write here west also. This is D long, and cos of latitude, which is cos of 56 degree, 56.6 minute. So from this we can easily find the value of D long. The value of D long is 120 divided by cos 56 degree, 56.6 minute. Now let's use this calculator. This is 120 divided by cos of 56 degree and 56.6 minute. Well, the answer is 219.99, or simply we can write 220. We can round off to 220. 220, and the naming, since it was west, so I have to name as west here. Now this 220 I have just divided by 60. I will get the value, which is 3 degree and 40 minute west. Well, the value of A is already given, which is 040 degree, 15 minute west, and the value of D long is given. The value of D long is 3 degree and 40 minute west. We need to find the value of B. Well, this is west, and then you are going further west. The longitude of B will be okay. We need to add 040 degree, 15 minute west, plus 3 degree and 40 minute west. So it becomes how much? It becomes 15 and plus 40, it is 55, and this is 043 degree, 55 minute west. So now let's summarize the answer. So the latitude of B will be same, which is 56 degree, 56.6 minute north, and longitude of B will be 043 degree and 55 minute west. This is the answer. Now let's solve this problem. In what latitude will a departure of 275 miles correspond to a D long of 6 degree 50 minute? So we know it very well that relationship between departure and D long is simple, that departure is equal to D long into cos of latitude, and this is the parallel sailing formula, as I have already discussed. So here the value of departure is there, which is 275 mile, and the D long, the value of D long is 6 degree 15 minute. Well, we can convert this into 6 degree, that is 300 okay 60 degree. All right, 360 degree plus 15, that is 375 minutes. Okay, let me just correct. This is 360 minute plus 15 minutes, so 375. So 375 into cos of latitude. So this way, let's simplify. Cos of latitude is 275 divided by 375, or latitude is equal to, I think I have to use the calci now, and the use of calci is very simple. 275 divided by 375. 375. We get this value 0.7. Okay, then cos inverse like this, and I get 42.83, or let's me press it this 42 degree 50 minute and 0.3 second. Well, we can ignore this 0.34 second. Now the value is 42 degree 50 minute. 42 degree 50 minute. Now the question is whether I should write north or south. So suppose this is the earth and this is the equator. These are some meridians. So suppose this is the D long, which is 375. Then departure is 275 here, which can be in the north side also, and it can be also in southern hemisphere. Let me just write here north pole and south pole. So the latitude can be this one, 42 degree 50 minute and 42 degree 50 minute south, and that can be north also. So let's write the answer north or south. So let's work out on this problem, which is in latitude 49 degree 10 minute. The departure between two meridians is given as 350 miles. Find the D long. Again, it's a very simple problem. That departure is equal to D long into cos of latitude. So the D long will be departure upon cos of latitude. So the departure is 350 and latitude is cos of 49 degree 10 minute. So let's solve this problem. Let me just put it this way, 350 divided by cos of 49 degree and 10 minutes. So I get this value, 535.28. Well, that is a value you get in minutes. So I'll just divide by 60. So I get direct value, which is 8.9 or 8 degree 55 minute and 16 second. Well, 16 second, the round off I can write as 18 second, which is 0.3 minute. So 88 degree 55.3 will be the answer. The answer will be 8 degree 55.3, and it can be either east or west depending on the direction of travel, because that is not stated in the problem.